So in this video, we're going to focus on the concept of lists, stacks, queues, and priority queues. First, okay, we have seen, or in the previous one, we have seen the collections. List implements collections, okay, and collection is an interface. So we know that choosing the best data structure is very important to make your program run better or have high performance. So an interface has the collections interface, and this interface defines common operation of the list, vectors, stacks, queue, priority queues, and sets. So we have seen the method of the collections here. At all, clear, contain all, equals, hash code is empty, iterator, remove all, retain all, size to array. You can see that definitions here and explain description down here. So this has to be implement inside the list once the list implements this collection interface, right? So Java Collections Framework support two types of containers. One for sorting a collection of elements is simply called a collection. So if list implement collection, list has to have those methods that we mentioned earlier. Vectors, stacks has to implement them. And the other for storing key value pairs. So that's why we said that another type we call maps. So if you use map, okay, let's look at this image. All right, so that's why we said, hey, list is going to implement this collections interface. Set also, then they have to have other operations. But map doesn't have to, right? Map has its own interface, map interface. Because map has a key and value pair, right? So let's look at the map. So we see collections. This is an interface named collection E, could be any type. So we can look at the map interface. So it's different. So you see the generics has key and values, right? K, comma, V. So that's the two, right? In the generics. K is the key and V is the values. Like I told you, example could be the dictionary. We have the word as a key and V just return the definitions. Or you have employee ID as a key, student ID as a key, and returns the object, which is the values, user values, students object back. So that's the key values. That's the map interface. This is an interface, right? And if you look at methods, clear contains key, contains value. So that's why it's different, because you want to check the key. If it's contained this key, contains the values instead of the key, we can look at the values too, right? Entry set return a set view of mapping contained in this map. Equals get, right? You can pass a key and get the value back. Get the hash code. Is it empty? Right? Is the map is empty? Key set return a set view of the keys contained in this map. Right? So just return as set, right? Like set2. Now put all, you can do put the key and value. That means you pretty much add the items into the map, right? With a new key, with the new values. You can put all from another map to this map. Remove from the key, find the key and remove that out. Size and values. Return a collection view of the values contained in the map as a collection back. Right, so those are the method for the maps. So we see that supports two types, collection and the map. Maps are efficient data structure for quickly searching an element using a key. We use a key to search, so it's going to be more efficient to return back. We will introduce map right in the next chapter. So now we focus on sets. Store a group of non-duplicate elements when we talk about sets. When we talk about list, store an ordered collection of elements, right? So it's in order. We talk about stacks. So store objects that are proceeded in a last in first out fashion. So what's stack? It's like you have a stack of a book, right? So let's look at a stack of a book. That is stack. What do you say again? Last in, first out. I have a new book stack on the top. That's the last in to the stack. When I remove, it's going to be first out. Right? You have to remove the top in order to get to the next one, right? Last in, first out fashion. That's a stack. If I try to get to the last book in the stack, I have to remove all the top. I can't just pull it out, right? Now let's look at queues. Store objects that are processes in the first in first out fashion. That's what we are normally do, right? If you're a good human manner, you will respect people who come first. When you go on the line of your grocery store, your McDonald's store, you not cut off the line. That's a queue fashion. We all know that. First in, first out. First in, first out. Now, what's priority queues? Is store objects that are processed in order of their priorities. It's like similar to the queues, but we have one exception. Like if you're a disability, you go first. Right? We have priorities first. So we said, okay, ladies, kids, children, disability, go first in the queue. Make sense? Sometimes we have exception in the queue. So this is called priority queues. So now the common feature of this collection are divided in the interfaces and implementations. Like we already see that common features is in the interface add, remove, contains. We see the interface. So implementation are provided in the concrete classes who implement the interface we call concrete classes, like list, vector, stacks, queues, priority queues. So let's take a look at how the collection interface is being used. So this is an interface on the left. So we said we have another interface named set. So we want to add more methods to use in the sets and list and queue, right? Now this is pretty much the same image that we've seen, okay, in the collection image right there, right? Set, queue, and list. These are interfaces, right? We just turn it around. And we said set has sorted set. Okay, like we said, list is in order, but set we can sort it that too. And navigable set interface. These are interfaces. Abstract classes. So abstract class, like we said, abstract interface has no implementation. All the methods are abstracts. Abstract classes, some of the method can be implemented. And why do we need an abstract class? We want to create this to make it extend to a concrete classes. Like to share. Like for example, collection. We have abstract collection. Right? So some of the methods are similar in the implementation, then we make it here. And then we can separate them, like abstract set implements the set interfaces. Then we can add more method into abstraction set. And also, as well as the list has a list interface, we can add more method to abstract list that we can implement it. Because we know that some of them are common to use, like array list, start to. This is concrete classes. That means all the method has to be implemented at this point. When you extend from abstract list, the abstract make it as a template for the concrete classes to use. Then you can start to. Some of the methods are commons. We don't have to reinvent the wheel again. Put in an abstract. Then vector can share that. Array list can share that. But vector may have some that they have to implement on their own. That's why we have to extend from that abstract list as well as array list. And then we have stack that extends vector. As well as the set, we have hash set extends from abstract set. And then we have linked hash set. So linked, this is the concept of the linked list. Okay. And array is the concept of using array. Now, so let's review the concept of array and linked list one more time here. That we already know array. Array is based on the index, and these are the elements that contains in the array. You can get to the index, then you get the elements back. Access. That's how you access the elements, or store by the index. But in linked list, it's just an object that contains two values. One is the element's values, and the other one is the pointer to the next element. And this has the pointer pointing to called LL, stand for linked list. Pretty much just the list of objects with the pointer keep pointing. And the last one pretty much is pointer just pointed null. So if we come back to this, you may see this hash set use the concept of linked list. Okay. And the array list use the concept of array to implement. It's all implement the list, but they just use different concepts. Abstract sequential list use linked list, right? So for concrete class extends the abstract sequential list. Look at queue. So we already understand what's queue, right? First in, first out. DQ, that means the operation that you can remove the first out. So we have an interface for DQ. Linked list happen to implement that DQ interface. So linked list has to implement all the method that listed in DQ. So that means linked list is going to support queue, right? Because it implements DQ. So if you happen to deal with first in, first out, then use linked list from the collections. But if you don't need to deal with queue, like list, you use array list. But if you have to deal with set, then use link hash set from Java collection. Okay, or tree set. So this is going to be based on the tree structure, and we will mention that later. Now we talk about priority queue. It's also extends from abstract queue. So this is based on the priority, which is queue based. So these are the classes that you can use. So pick the right one for the right type of your application. Again, if there's a priority, use priority queue. If it's just queue, no priority, linked set list. If it's just a list, order stack or array list. It depends. Stack is in the fashion of first in, last out. If you talk about set, no duplicates, linked hash set or tree set.